So first up is Obie. So Obie is the CTO of Andela, and Obie's going to talk to us about software development and specifically how that can be enabled with AI from his experience of actually building Olympia.chat. So give it up for Obie.
Everyone hear me okay? Good morning. Good morning. You made it on time. I don't know if that's impressive in Nashville, but I live in Mexico City and the traffic sometimes has its way of affecting timelines. But yeah, who else is a speaker here? Yeah? It's good to go first, right? Then you can just get it out of the way. So I used to be the CTO of Andela, probably one of the biggest gigs I ever had back in 2015. But these days, I'm working with AI. My partner and CEO, Victoria, is here. So you can find us afterwards and ask us questions about the talk and what we're doing. What I'm going to talk about today, and hopefully most of you have done at least some programming or do programming on a day-to-day basis, is how to apply AI to your day-to-day programming. So it's something I've been doing for close to 2 years now, ever since ChatGPT got popular and the API became available. I started using the GPT models in my day-to-day programming because I thought it was a cool hack. Like basically have these little black box components that you could integrate to do cool things inside of your current code. So just in terms of setting the context and just giving a brief introduction to what I'm going to do, I'm not here to talk about like big picture stuff, like how AI will affect software development in general. I'm also not here to talk about like how AI is used in a co-pilot kind of way to like help you write code. What I'm most interested in is how to use AI inside of your existing day-to-day code. So I'm going for maximum applicability here, because a lot of us don't have the benefit of just starting a greenfield thing, like, oh, I'm just going to do a new AI-based photo album or dog feeding schedule. I don't know. Everyone's doing everything in AI, but a lot of these things are either silly or just not applicable to the rest of us because we have jobs, we have software to maintain, we have legacy stuff. And to that effect, I've actually written a book, and this talk is inevitably going to end up kind of plugging the book, but that's not my intention here. My intention is to show you that there are patterns that I think are emerging, and I wanted to like apply some labels, some names to those patterns, so that as they come up, in your day-to-day requirements of what you're doing, you have a name to attach to it and say, oh, that's a predicate, or that's a ventriloquist pattern, or whatever the case may be. And the key question I have there on the slide is, how do you apply this approach without changing everything? Because AI is overwhelming. I mean, nod your head if you feel like this whole field is just overwhelming. Like all you have to do is subscribe to 1 or 2 newsletters, and it's just the bombardment, the fire hose of almost every day. I mean, I subscribe to like 6 or 7. Bless my heart. It's just too much to keep up with. It's overwhelming. But so the question is, how can I apply this without having to change everything about what I'm doing? Because if I tried to change everything that I'm doing, that's just not going to work. Because there's too many patterns in the book to actually go into in a half-hour talk, what I'm going to try to do is to describe one of the abstract patterns and at least 1 or 2, and I can do up to 4, depending on time constraints. And for each one of these, I like to make my talks interactive. So if you have a question or you want to stop me for a second, just pop your hand up, okay? Real quick, the reason I'm qualified to do this is not because I'm like a machine learning specialist or anything like that. I've actually been doing full stack software development for almost 30 years. I was one of the first people in the world to do server-side Java back in 1995. I kind of made my name in that space by blogging about it. I did it for 9 years. And then in 2004, I met Ruby and fell in love. I know there's a lot of Rubyists in here as well. So in 2005, I was one of the first people in the world doing Rails commercially at ThoughtWorks, and we kind of led the adoption of that in the enterprise at a lot of big companies. So right now, I'm chief scientist of Olympia, and what Olympia is doing is trying to build you an AI-powered workforce. We started with AI consultants, expert assistants that help you with marketing and legal and things like that. But I've pretty much been building this almost entirely by myself for the last year and a half. So there's a lot of things that I've done in this product, which I then used as the source material for the book. So I basically pulled the code right out of Olympia to show it in the book. Raise your hand if you've actually read my book already. I know there's one or two of you. Okay, so it's one over here. Okay, cool. So none of you have seen it before, so it's going to be fairly new to you. And I think, well, let's see. Let me not hype it up too much. So first of all, these are the abstract patterns. I'll give you a second to kind of read through them. I'm not going to read the whole slide. I'm going to point out a couple that you might not be familiar with, because I'm pretty sure all of you here know what RAG is. That's one of the most common techniques. And you probably all are at least passingly familiar with the idea of tool use, which is that you can give functions to your LLM. Some of the things you might not be familiar with, and again, these are abstract patterns, is what I call narrowing the path. And the reason I included this in the book is because back when, what actually tipped me into writing this book was that I was giving a talk on AI, and a friend of mine, old friend of mine, Tom, was in the audience. He raised his hand and he said, hey, this all looks amazing, but where do I get started? Because I have no idea about AI just to begin with. So I said, okay, putting myself in the mindset of someone who's just starting out, there's a fundamental thing that we need to understand, which is the latent space, basically this idea that LLMs command this huge multi-dimensional universe of knowledge. And one of the fundamental things I didn't necessarily get from the introductions out there and the primers out there is that a lot of times the reason that our prompts are not working, or the thing that we're trying to do is not working, is because we haven't narrowed that latent space enough. So understanding the framework of, understanding the frame of needing to narrow down the choices of the AI when it's trying to do something for us was very useful for me. There's also one more that I want to call out. Let's see, I got a laser here. Okay, multitude of workers. So this is one that I don't necessarily hear a lot of people talking about, but there's a lot of talk of agents and what agents can do for your for your users, or for us as users. But one of the things I find useful within the architecture of my app, when I'm thinking of how to design collaborating components, is to kind of think of these like little humans, that can collaborate in my app and do very specific, narrow things. So I'll talk about that as well. And other than that, there's some other ones, but I do want to mention the concrete patterns, and there's quite a few of them. I started out thinking I had a dozen, and then as I was writing the book, I just kind of kept discovering more, and I actually have one more to add before I call the book finished. The book is at 99%. But I'm going to talk about a couple of these as well during the talk. You all familiar with the Gang of Four patterns book? That's the classic, right? That's where we get proxy and adapter and strategy and some of these kind of really basic software architecture constructs, the way that you design your code. And then an old mentor of mine at ThoughtWorks, Martin Fowler, wrote a very, very famous book called Patterns of Enterprise Architecture. What I'm trying to do here is kind of establish a similar sort of thing. The idea, like I said before, I'll just say it one more time, is that some of these things, to me, kind of have obvious names, and establishing the names that we use to refer to these concepts kind of helps us collaborate and know what we're talking about amongst ourselves. So anyway, let's jump into it. I mentioned the four multitude of workers. So the idea is to decompose your workflows into collaborating components. And I think that this idea that you have like kind of human workers, it helps you if you're in a position to have to explain, especially to a non-technical stakeholder, what AI is capable of doing and what you're capable as a developer of doing with it. And the reason that I'm finding this very, very valuable is I've been in the position to have to explain that, and I think there's a lot of magical thinking going on right now out there. There's a lot of non-technical business people with ideas. They're seeing the same headlines we are. They're seeing the write-ups about how smart AI is and everything. They're going, oh, this can revolutionize my business. So, for instance, I had a call with a fellow who's very well tied into the biggest reinsurer in the world. You can imagine who it is. And he was describing to me kind of his idea for how you could use AI to improve risk assessment and the ability to calculate on the fly what premiums should be. In case you're not familiar with the insurance industry and how it works, a lot of the premiums, even what's paid at retail, ends up getting defined by the reinsurer. So it's in their best interest. If they can improve their performance by like a fraction of a percent, that's hundreds of millions of dollars right off the bat. So this guy who's very well tied in, he's got money, he's got connections, and sure, he wants to do a startup, and he started telling me, well, AI can do this, AI can do that. And I wanted to know exactly how he thought AI was gonna do that, and he was not technical, so he didn't know. So I started walking him through the process. Okay, well, what is involved in determining the risk for a particular policy? And that involves an actuary that's actually looking at the data, and then there's a lot of data science going on, and these actuaries and these specialists that calculate risk have their spreadsheets, and they have their models and their databases that they use to figure this out. And you say, well, we could just get AI to do that. Without getting too much into the gory details, what I ended up kind of leading him down a mental path of thinking about is saying, okay, as opposed to having a black box that just kind of like magically does this thing that you want to accomplish, what could you do if you had an army of robotic actuaries, essentially, a multitude of workers that would be completely infeasible? Because as soon as we got into like how one of his human actuaries would do the thing that he wanted to do, he had an idea of how to specifically improve a particular kind of risk assessment, right? So I was saying, why can't you get a human to do this thing that you want to do? And the reason, well, humans have their own ideas about how they should do things, and they have their own limited data sets. They don't want to use the big data sets I can give them. Stuff like that. I was like, okay, good. That's a good starting point. That's a good foundation for thinking about it. Because the AI is not going to give you lip. It's not going to give you pushback. If anything, they're too helpful. They're too willing to go along. So I said, okay, that's a good starting point. Like, can we prototype one, AI actuary doing this thing? And we went through it and we figured out, if we could do one. And then the question is, okay, if we can do one, can we do 1 million? And does that help you? So it's a mental framework for thinking about it. When it comes to integrating these kinds of things in my code, the name I applied to this, and this is kind of like the general concept, is a discrete AI component. So if I talk about my Rails app, Olympia, for instance, is a big Rails app, monolith, but it has some discrete AI components in it. So the idea is that these discrete AI components exhibit intelligent behavior. Someone in a talk asked me, Obie, why do you say intelligent? And I figured out, okay, I better kind of talk about what I mean by that because it's a loaded term. Intelligent in this context is an adjective that I think is useful to distinguish between AI components and kind of normal code components in the sense that my AI components can be more resilient, right? Because they have semantic understanding of what you're throwing at them. So you can write code that is more resilient, more extensible, because potentially the way that you're instructing these components on what to do is in plain language, which means that sometimes you can extend them just by changing the language that's going into them. And you know, as we get into describing them, there's other ilities, right? There's other non-functional requirements that are improved by using these kinds of components. So, amongst other things, and it's what I want to highlight to you today, you can declare parts of your business logic in plain language. And some of you may have started doing that as part of your application development methodology years ago. I know I did. Back when I was running an agency called HashRocket that some of you may have heard of if you've been around long enough, we were pushing the envelope on some agile, you know, technical techniques, including behavior-driven development. And what behavior-driven development lets you do is to involve non-technical stakeholders in defining the requirements of the system by writing them out in English. And when you write out requirements in English, you know, back then it was just kind of cool that it was something that could form the basis of a conversation between the business analyst or the, you know, whoever's defining the requirements for the system. Now I look back on that stuff and I say, wow, a lot of this looks like prompts. A lot of this looks like instructions that I could feed to an AI in order to tell it what I want my system to do. So this definitely influences my thoughts on the subject. But the idea is that modularity and message passing, which object-oriented you know, teachers, proponents have been telling us for decades now, since Smalltalk, to think about your software components as passing messages to each other. That's not always so obvious when you're working in the binary realm. You know, you're like sending structured data between components or you're doing function calls. We want to think about it as a function call or method call. But with LLMs, you can actually pass English messages to each other. I'm not saying this is the most efficient thing in the world. I'm not saying this is going to work for every single use case. But the fact that your discrete AI components can talk in quotes to each other in English is actually pretty interesting. I've just thrown up a very simple example that, I don't know, makes 100% sense, but you know, I have one component here is saying user, you know, whatever, hasn't logged in recently, and then there's another component which in theory is responsible for retention, and it says, let me look at their activity history. Okay, I'll send them an email about our latest feature. Knowing that AI has a certain amount of intelligence, you can think about a retention component that has the ability to look at the behavior history of a user, and also has the ability to kind of look at what's going on in the company to select for some retention strategy, let's say. That retention strategy might be to send them you know, an email with, hey, these are features you haven't used yet, or something like that, right? Definitely influenced by microservices approach. I was a huge fan of microservices as taught by Fred George and a number of other kind of luminaries at the time. And when AWS Lambda came out, I found that it was like a great platform for building microservices. So I did a lot of experimentation there. I kind of half wrote a book about it. To me, these discrete AI components can function as microservices kind of within your system, whether it's a monolith or it's distributed or whatever. Doesn't really matter, but when I was learning about microservices, the way I was taught to think about it was, you know, with a message passing kind of style, where it had like a responsibility and you told it to do something and then it told you what it did. So that kind of maps very cleanly to it. So I want to give you an example here, and this is actually drawn directly from Olympia. itself. So this is one of our account manager components. Tend to write them in a granular way, so they kind of have like just small responsibilities, because the level of intelligence of GPT-4, which is what drives this right now, is not so high that I can just kind of throw all the customer service at it and have it reliably work. But in this case, this particular account manager is responsible for being able to add a new assistant to a user's account. So the part that is most relevant is the user will request changes to their account. You will process those changes by invoking one or more of the functions provided. And the functions provided, I'll come back to that in a second, but they include things like adding a bot config to an account. So like basically, this particular account manager component has functions that allow it to do things like look at the state of an account, and also to add a bot config to a particular account. It also has other things it can do, which I didn't have room to, kind of get into the gory details here, but it can send communications to our customer service team, and it can send communications to the customer itself. So I kind of give it these tools to do its job, per se, and then I tell it what to do. I'll just go ahead and read this for those of you that might not be able to see it because it's a little small. Do not allow the user to change their account or add a new AI assistant unless their account subscription status is active. Make sure to notify the account owner of the result of the change request, whether or not it is successful. So the implementation of the account manager is that it gets a change request object, which it can manage. It's kind of like a ticket. And then always end by calling the finish function so that we can save the state of the change request as completed. So when the account manager has a task to do, it's getting a plain text message from another component of the system. This is not something that's being driven by the user typing some English into a prompt box. This is being driven by the user clicking a button. And when the user clicks a button, that actually sends a message to this component that says, please add bot config UUID to user UUID. Go ahead.
Why not just write the post request that way?
Because that would not be so cool.
That's the answer. That's cool.
I mean, that's the most accurate answer I can give you, yeah. I'll get into a slightly more nuanced answer in a second, okay?
How is the prompt finding the right action in this context?
This is the system directive of that particular component.
Got it.
I apologize that the font is a little small, but you can see the system directive here.
Yeah.
And I warned you in the beginning of the talk that this is going to end up plugging my book. It's not the only reason I'm here, but this is described fully in my book. So if you're interested in this approach, it's in the book. But anyway, the system directive is here, and then I'm using a framework that I wrote called RAIX, R-A-I-X, and that framework gives you things like chat completion and function dispatch. And so the functions are declared with kind of a Rails-style DSL here. I'm blocking this screen, sorry. So this is a declaration of the add bot config to account. And this is not AI code. This is just normal procedural code, right? If I was to show you this entire source code of this, you would see more function definitions. So you would see a function definition for being able to pull up the account status, for being able to communicate with the user, being able to communicate with support, and being able to finalize the change request, okay? So I roll this out, and this is where I want to get into the more nuanced answer, okay? So actually, the first version of this component did not have this part that's in green. That I have boxed out here. So this sentence was not present in V1. We rolled it out, and very, very quickly, within like 2 or 3 days, I got a Slack message from JP in our customer support, and he said, hey, We had a case where this failed because someone who had a canceled account, who was scheduled to cancel, actually added a new bot. And since a new bot involves billing and whatever, we had discussed it and we decided we didn't want to do that. So he said, do you want me to add a story for it? And I said, no, I got it, because I was already in the text of the directive and I added this sentence. Do not allow the user to change their account or add a new AI assistant unless their account subscription status is active. So literally while I was chatting with him, he said, I have a new requirement that you didn't capture in your code, which is that, you know, we don't want to allow this behavior for account statuses that are not active. And I just popped in and I added that. Did a little bit of ad hoc testing and determined that it worked. I saw a hand shoot up, yeah.
Well, obviously the other way you can do this, right, is you put in code to say,
Yeah.
like, check this thing, and then you can unit test that. And that's like, you're also kind of mixing function calls with these prompting. So I guess one is, how do you think about testing this?
Mhm.
Making sure that like this is actually working, because this could be a more important state. Like it could do something that you really like as a negative action.
Yeah, I mean, your mileage may vary with this approach, and refer back to my earlier answer. At Olympia, it's really just me developing this. I have another part-time developer who kind of does some of the features, but I'm kind of responsible for the whole thing in terms of the architecture. So for me, it's not a big deal. Like, I'm okay running seat of the pants, with some of this stuff because it's cool. Is this going to kill someone if it malfunctions? Then yeah, probably test it much better.
But sort of following on that, because I presume that you've limited the function calls it has access to, and so even within that, like the scope of what the bot can do is limited, and so it's to the point of like, yeah, it might misfire and it might do something it shouldn't, but that is still scoped because it only has like 5 other API calls that it can actually make within its like action set. Is that
Yeah,
your assumption?
that is correct. And another thing I'll add, because it's a popular misconception. Let me repeat that for a second, just for the whole room, okay? So there is a limited set of functions that this particular component can call. So its tool belt, the things that it can do, it's not like it has access to a shell, or like the whole API of the app. It has very specific functions. So it's limited in what it can do. And you can test it fairly easily. In fact, I test these things, from an integration kind of, not a unit test, but kind of like, does it do the thing it's supposed to do? Fairly easily. And there was one more thing I wanted to add. Yes. So I've shown this to people and they literally go like this. No, they go, AIs hallucinate. Like, are you crazy? Couldn't it just hallucinate something? Couldn't it just talk, tell the customer something rude or something like that? Because this has access to talk to the customer, it can send them emails, right? So they go, are you crazy? AIs hallucinate. I go, no, they don't hallucinate that bad, actually. I mean, there's probably failure modes that I haven't encountered. There's probably ways that if an end user got into being able to message this thing, they might be able to exploit it. Absolutely, I 100% agree. There's probably like prompt injection things if you give the user. But I did say earlier, and very clarified, an end user does not have access to this thing. This is actually serving the inside of the app.
They don't have, if you try to hack into like the front end API request.
It's not coming, it's not like English. The prompt for this thing is not embedded into a button in the website or anything like that. It's at the controller level.
Yeah, so a quick question. How do applications like this handle hallucinations? Do you have to add specific code to, excuse me, how to clean that up, or how do you handle that?
So the question is, how do we handle hallucinations for this thing? I take this with a grain of salt, but in my last year and a half that I've been working with this stuff, hallucinations for this kind of approach just don't work that way. right? So it's not like this is going to start giving me a Lord of the Rings monologue, you know, and break my system. You know, what it'll do sometimes is just get it wrong, right? Like just not call the function correctly, you know, or not pass the parameters correctly, you know, to the function or things like that. And that actually happens very little, like surprisingly little. GPT-4 and above is incredibly good at things like getting UUIDs right.
With code at scale, you're going to have failures anyway of anything.
With code at scale, yeah, with code, I mean, yep.
Let's do one more question, and we'll wrap it up.
Oh, wow, I'm done already? Okay, no. Okay, I want to get past this just so I can like show you one prompt engineering concrete pattern so that we can, you know, you can kind of understand what I mean by the difference. So we've been talking about a more abstract pattern. I wanted to give you at least one concrete pattern. That's why I left this flexible. The structured I/O pattern, you may or may not have seen this kind of approach, but the idea is to provide to structure your prompt in structured data. And my hot take on this is that XML is going to stage a comeback because it's actually easier to work with LLMs in XML than you would think. It's actually much easier in JSON, I find. Don't shoot the messenger. But you know, the idea is you can clearly delineate kind of what you're after and structure it in XML and then ask for your output in XML, and it's very, very good at generating XML. And then you can parse it out super easily. So here's an example taken from the book. So like I give it the description in tags so that you're already grounding it in an XML context. And then I say extract name, size, price, and color. And just by doing that, it knows what I'm talking about. Like it knows what I want. And this works very reliably where it'll extract. And the fact that it's giving me XML back means I can just throw it into a parser and be done. You know, it's actually not hard. So.
Super fast on that. So you're saying XML is working better than JSON for writing the prompt. Do you feel like it actually also outputs like easier to manage? Basically, that the output is XML is easier to manage than JSON.
I personally find like in terms of implementation code, I actually find that it's easier to work in both directions. Yeah, which was super surprising to me when I ran into it. I was like, wow, okay, very interesting. We have time for one more. Oh,
Yeah, you got time for one more question.
okay. Anyone have a burning question? No? Okay.
What was the name of the workers pattern the first word before that?
It was just multitude of workers. Yeah. Yeah. We got one more minute?
Sure, one more minute.
All right. This is a cool. I just think it's named really cool. So the ventriloquist pattern is when you actually talk on behalf of the AI. Anyone tried this? Yeah. Let's see, a couple of people. So the idea is you want your prompt to be handled in a certain way. This is an example of narrowing the path. So the idea is that I actually temporarily use the AI, you know, kind of stick my hand up the AI's rear and, you know, sock puppet it. Say, okay, you're saying this. So you preload an exchange between the user and the assistant responds in a certain way, and then the user gives it another prompt, and then you wait for the AI to respond.
Awesome. All right.
Okay.
Thank you, Obie.
Yeah.
Give a round of applause for Obie.
Good for time. The book's on LeanPub, by the way, if you're looking for it, and it'll be on Amazon later this year.
Awesome. Thank you, Obie.